So this video is going to be the second part to the solving equations video we did earlier. And in this video, what we're going to be doing is tackling more complex problems and solving these equations. So the first example we're going to look at is an equation with fractions. So right over here, and as you can see, the equation is 3/4 x plus 2 equals 1/8 x plus 3. So the fractions might seem very daunting to a lot of newer students to algebra, but really it's very easy, and there's multiple ways you can go about this. You could use the traditional equation solving method of just subtracting, combining like terms first. So it's just subtracting 1/8 x from each side, converting this fraction, converting that fraction. But really, that's a very slow and tedious way to do it, and all you're doing is creating more work for yourself. Really, what you want to do here is you could multiply this entire equation by a number that will turn all of the numbers to whole numbers, right? So the number, in order to find what number we have to use to multiply the entire equation by, since you're multiplying what you do on one side, you do to the other, you have to look at the denominators of the fractions, right? So we were given a pretty good example here, pretty easy one, because 3/4 1/8, 4 is a factor of 8. So you can multiply both sides of 8, and that will get rid of all the denominators and give you all whole numbers, and it'll become just very nice and easy to combine all the like terms. So let's do that now. When we're multiplying everything by 8, you have to make sure to distribute. So we have times 8 on this side, and we have to do the same thing on the other side, times 8, right? So doing this, by the way, if you don't know, the dot or the circle, whatever you want to call it, is another way to portray a multiplication sign. So we can cross out this 8 with this 8, right? And that will give us 1x. And then the 8 doesn't get permanently crossed out, only for this fraction, but you have to distribute it to the other number as well, which is 3. So 3 times 8 is 24. So on this side, you're going to have the expression of x plus 24. Okay? Now you do the same thing on the other side. When you cross this out, you get, with 8, you get 1, and you get 2, because 4 divided by 4, 1, 8 divided by 4, 2. Okay? And 2 times 3 is 6. So on here you would have 6x, and then actually what we're going to do here is take that out, because it could seem confusing when you distribute it to the other number. It doesn't maintain this cross out thing, so you wouldn't multiply 2 by 2. So I'm going to erase that just to keep it more clean. So we're going to have 6x here, and when you multiply 8 by 2, because you're distributing, you get 16. And here we have the equation 6x plus 16 equals x plus 24. So now it has become like any normal equation, and you can just use normal addition and subtraction operations to combine like terms. So what we're going to do here is subtract x from both sides, or you could just subtract 16 in the beginning. It doesn't matter which one you do first, but as we know, same thing on both sides. So we get 5x plus 16 equals, the x's on this side eliminate, and you bring down the 24. So 5x plus 16 equals 24. Now what we do is we subtract the 16 from both sides, because you want to isolate the variable on one side and isolate the number value on the other side. What you do on one side, you do to the other, So subtract 16 on both sides. 16 gets eliminated on the left side, and on this side you're left with 8. And bring down the 5x. So here we have 5x equals 8. And it looks like we're going to have an improper fraction solution. So what we're going to do here is isolate the x. So divide by 5 on this side. And what we do to one side, we do to the other. So divide 8 by 5 as well. So the 5's get eliminated. And you don't have to, when you're solving equations like this, you don't have to punch this number into a calculator. Usually your teacher will just want you to leave it as an improper fraction for the sake of simplicity. So for your final answer, you're going to get x equals 8/5. And that is your answer for this problem. In order to, I never went over this in the last video, I probably should have, but in order to check your answer, in this case, what you would want to do is take this value that you got for x, so 8/5, and plug it back in to the original equation. So substitute 8/5 for x on both sides, right? And do the entire equation out. And if both sides are equal to each other, then that's how you know you got the answer right. So that's just a way of checking if you got your answer right or not, or checking if you got any silly mistakes. As you get more and more comfortable with solving equations, you won't really have to do that. So for the sake of time, we're not really going to do it in this video. Our next complex equation that we're going to look at is what if the variable is in the denominator. So this is something that catches students off guard so many times because they don't know what to do with the variable, because they think it'll just disappear out of thin air if they multiply it. But really, it won't. What you can do here is multiply both sides by x. It's similar to what we did here, except in this one, we're doing it with the variable. So if we were to multiply the entire equation by x, we would do it to this, and we would do it to this. But you have to make sure to distribute the x to the entire equation, right? So the x's on this side would be eliminated. You would be left with 4/1, which is really just 4. And on this side, you would have to distribute the x. So you would get 2x. So really the x is still there. It didn't disappear at all. And the 3/x would become a 3 because the x's here would eliminate. So now you're left with another easy to solve normal equation. 4 equals 2x plus 3. And really you can just repeat the steps that you've done before. Very easy stuff. So 1 equals 2x. Because 3's get eliminated, bring down the 2x, and 4 minus 3 is 1. And now you just divide both sides by 2 to isolate that x. And what you get is, I'm just going to swap the sides here because it looks better. So x equals 1/2 is going to be your answer. And again, you can check this answer by plugging it back into your original equation. So you would do 4 divided by 1/2 equals 2 plus 3 divided by 1/2. And yeah, and you would see if both sides were equal to each other. If they were, then that's how you know you got the answer right. Next, we're going to do an example with parentheses. So the reason why this may be very lengthy is because you have to constantly distribute the numbers, and then you would have to, solve the equation out. So it becomes a lot more tedious because you can't really, like with these fractions, you can't just multiply everything by one number or divide everything by one number. But if, say, we had like these two alone, then what we could do is we could divide by 2, get rid of that 2, and then divide by 2 on both sides and make that 4 into a 2. So you could simplify the coefficients down to sort of get the numbers down a little. But given that we have these pesky constants here, we can't really do that. So what I'm gonna do here is I'm gonna carry all of the constants over to one side. So I'm gonna do -1 on this side, -1 on this side, same thing on both sides, and you're gonna get 2 plus 2 times x minus 1 equals 4 times x plus 2. So as you can notice, we still haven't distributed because we can actually take a shortcut here. And the shortcut is going to be dividing everything in this equation by 2. The reason why we're doing that is to cut down the numbers because every single coefficient is divisible by 2. And the coefficients are what controls the sort of value within the parentheses. So you don't have to worry about dividing the things inside of the parentheses by 2 because the coefficients are controlling the quantity of that. You can sort of look at this x minus 1 as x, essentially, as a sort of its own variable. So really, if you were to look at that, like say x minus 1 as an x, then you could just say, oh, then maybe I'm just doing 2 plus 2x equals, and then maybe the x plus 2, look at that as a y, because x plus 2 and x minus 1 are not the same thing. So 4y, and then you would feel more comfortable dividing all these coefficients. But regardless of how you look at it, when you divide by a number, you just divide the coefficients, not the numbers in the parentheses, because those coefficients, as I said earlier, control that quantity of what's in the parentheses, so to speak. So let's erase that. And now we're going to do what we said and divide everything by 2. Okay? And when we do that, we get, so this becomes a 1, because 2 divided by 2 is 1. This would become x minus 1, because 2 divided by 2 is 1, and 1 times x minus 1 is x minus 1. And this would become a 2 times x plus 2. Okay. Now the numbers have become much simpler, and as you can see here, we have a 1 minus 1, so that's just 0. So when x is already left alone on one side, right? So we can write that right here. And then on this side, we can distribute the 2 to the x plus 2. So now what we're doing is we're distributing. And as you can see, we only have to distribute one expression here, since we already took the other one down, took the coefficient of the other one down. So 2x plus 4. So now we have another simple equation to solve. And I'll write it up here. X equals 2x plus 4. What we're going to do is subtract 2x from both sides. Minus 2x. And minus 2x. So we can isolate the x on one side and the number value on the other. And we would get negative x equals 4. Now, I don't believe I have gone over negative variables before. So in this case, what you would basically do is just swap the negative sign. Essentially, it's the same thing as multiplying by -1 on both sides, or say dividing by -1 on both sides, because as I mentioned earlier, there's always going to be that invisible 1. So really it's -1x. So for the sake of comprehension, I'll just divide by -1 on both sides, and you see that x, because 4 divided by -1 is -4, x equals -4. So yeah, these are basically all of the sort of complex equations that you're going to be seeing. Not really complex, but stages of operations or different topics you're going to be seeing in complex equations. And in the next video, we are going to be going over how to discern between if there is going to be no solutions, um, all all solutions, like infinitely many solutions, or only one solution in an equation. So see you in the next one.